Welcome folks to our lesson on linear motion. This is linear motion SPSS. I'm trying to address problems that students have. Student problem solving session. In our study of linear motion, remember the key things we are studying here are distance, displacement, speed, velocity, and acceleration. Now, what we may use in this study may include stopwatch. If you want to know how a body moved from point A to point B, you may require meter rule to measure the distance. You may require a tape measure, and so on. Distance measuring devices. In addition to that, you may require a stopwatch so that when you calculate the distance moved over time taken, we can now talk of speed. But in laboratory, we may use what we call ticker timer. So the device that we are introducing is a ticker timer. It is a device that you use to study motion when the time required is very short, such that you may not use a stopwatch. The time change, the time that elapses is very short. In the laboratory, we use what we call a ticker timer. Now, a ticker timer is just a trolley which has a tape, and we put it on an inclined plane to have a runway which is free from any push. Remember, in the airport we have things like runway, where an aeroplane with the thrust from the engine, it can now move along the runway. In laboratory, we make a runway, just an inclination, so that when we put the trolley at the top and release our fingers, it is able to move freely. The trolley has a tape attached to it, and that tape is connected to the timer. The timer will be making vibration on that tape. For example, if my finger had ink, it would make some marks on this board. The time I take to make those dots is what we call frequency. If I make, those are 3. If they are made in a second, then I can say my frequency is 3 Hz, denoted by letter capital H, small z, Hz. So, what are we doing in the lab at this moment? Remember, when we release our fingers, the trolley will be able to move. So the trolley facilitates our study of linear motion. How? The timer makes the dot on the tape. The tape is just a thin piece of paper which is long, where the dots are made so that we can now sit and analyze the motion by the trolley. The trolley moves, it has a tape which is connected to a timer. The timer vibrates, and in doing so, it makes the dots on the tape. So when the experiment is over, we sit and analyze. And now I'm taking to a piece. So I adjust the camera now to a possible piece. You can see I've drawn a possible tape. This tape has dots. Okay? And I've said the timer has a frequency, e.g. 50 Hz. What does it mean? It made 50 dots in 1 second. On this tape, we can study the time taken to make one dot and the next. If I take example of these two, I have a distance between them. So if 50 spaces or 50 dots happened in 1 second, how long does it take to make one space? I want you to follow this keenly. I will do some side work here. I'll use black, that there were 50 spaces that happened in 1 second. Now I want to know what is the time taken to make one space. A space is made up of 2 consecutive dots, meaning what? The first dot is just a reference point. So if I have three dots, for example, here, 1, 2, 3. The first dot is a reference dot. It is the beginning of our measurement. Otherwise, we have 2 spaces. So you must understand the language in the textbook. If you count the dots, there will be 11. Yet we talk of 10 spaces. Why? Because the first dot is the reference point. When you measure length, you must have a starting point. So if I have 3 dots, the first one facilitates the beginning of measurement. But in real sense, we talk of 2 spaces. I'm talking of 2, in quotes, distances. So here, 50 Hz means 50 spaces happened in 1 second. I would like to know how long it took the timer to cover 1 space. You do simple cross multiplication. So this is it will be 1 times 1 divided by 50. Okay? What about if my timer has a frequency of 100 Hz? What does it mean? 100 spaces were created within 1 second. So how long does it take to cover 1 space? Again, I will do cross multiplication. 1 times 1 divided by 100. I want us to focus here. In studying linear motion, remember key things: distance, length of path taken, displacement, length of path taken in a particular direction, speed, rate of change of distance, velocity, rate of change of displacement, then acceleration is rate of change of velocity. In studying linear motion using a ticker timer, what are the key players? One, the frequency. The frequency gives us the time the timer took to cover a single space. So it is indirectly given in the form of hours. I want you to understand the role of each. Hours, frequency, will help you get the time taken to cover one space. Now, distance is measurable on the tape. You can use a meter rule. You can measure from point A to point B. If you are in exam, they may not give you the ruler to measure, but they can give you a scale. You have done grid or graph work. They can tell you a single square represents 10 centimeters. So what about if I have two squares? It will be 10 times 2 and so on. In a nutshell, the distance that you will have in a tape, we can measure them using our meter rule. May I add, we may use a ruler, but you must know the difference between a ruler and a meter rule. A meter rule has dimension right from the edge. There are Form 2s who are asking me. It starts from the edge, the dimension. But a ruler, if you check in your mathematical set, it leaves some spaces. And therefore, I told the Form 2s and 1s, you cannot use a ruler to measure a height. Because when you place it in effort to measure height, you will lose the measurement between the edge and the start point of dimension. But that is for another day. The key players' distance can be measured using a meter rule, a meter, or interpretation of the scale that you have been given. What about time? Remember, the frequency of the timer is to generate the time you take to cover one space. And therefore, if there are 5 spaces that have been covered, you multiply 1 over f times the number of spaces, where 1 over f stands for time taken to cover one space. So, if I focus now my camera, I conclude. This is my conclusion. We can focus down here. Yes, you can see here. Distance and displacement are basically the same. The difference is that displacement has a direction. So distance is found in displacement, but displacement is not in distance. What do I mean? Distance is length of path taken. So if I can measure from point A to point B, that is distance. The moment I give a direction, it becomes displacement. Time, SI unit is second. When you're given frequency, to get time to cover one space, it is 1 over f. So if there are 10 spaces, it is 1 over f times the number of spaces. I'm going to continue, folks, now with real situation on the ground. I will continue with analysis of the tape. Here is an example. This tape, I want to get the distance between the 2 points. all of you can see x. So the distance between the first point and the third point, meaning that I'm dealing with the two spaces, I've measured using a meter rule. It is 1 centimeter. Remember? Come to y. I want to get the distance between this and that. I've measured. I've gotten 4.7. It is as simple as that. So, in exam, you can get these lengths given. They have already been given. In case they have not given you, they will give you a scale for you to interpret. And if the two have not been done, they may ask you, using your ruler, measure the distances. Remember, they will have measured, so you cannot cheat. Now, what about if I wanted to know the time taken from the first dot to the third dot? Given that I know the distance, I need to know the time. So if my frequency is if my frequency is 50 hertz, then the time I take to cover one space will be 1/50. And how many spaces are these? You can see 1 and this is 2. So what is the time taken to cover this distance shown? It will be 1/50 times the two spaces. Okay? The same thing, if I wanted to know the time to cover this space and this space, I will say 1/50 times 2. Let us take this to be u and this to be v. That is, initial velocity is found here, and the final velocity is found there. Okay? Look at my diagram, and this is that. I want you to get what is initial velocity. And you know, I'm talking basically of speed. Why? Speed is quantified using figures. When I talk of velocity, it is that speed but in a particular direction. So when I talk about what is the speed here, I mean the figure. But when I talk of velocity, I know that that speed took place in a particular direction. My assignment is get for me u and get for me v. U is basically distance 1 divided by time 1. And here it will be v is equal to distance 2 divided by time 2. I will continue with this. I want you to subscribe so that you next you get the addition lecture, the addition skills in line with linear motion. We are doing linear motion. We cannot use stopwatch. We are going to use ticker timer. Reason being, ticker timer enables us to carry out an activity within a very short time, such that it is not possible to do with the normal stopwatch. Keep on subscribing. Till we meet, folks. Bye-bye.